6th grade. I guess it's time for another math lesson. I will share my screen. We will talk some math here. This ought to be about as exciting as it gets. I'll bet you can't wait, as always. Boys and girls, today we are talking about what's called prime factorization. Here we go, ready? Prime factorization. And simply what prime factorization means is, well, let's put this in here. This is also known as, AKA, it's, the tree thing. That's my favorite. It is also known as product of primes. It is also known as division by primes. Make sure I get that right. It is also known as factor trees. Factor trees. And division by primes. And in order for you to kind of get the gist of this, we have to kind of go back and make sure we understand what the difference is between a prime number and a composite number. If you go back and look in your notes, it's probably there, but prime numbers, simply, the definition of a prime number is that it has two and only, emphasis on only, two factors. Two and only two factors, where a composite number has more than two factors. Has more than two factors. And the gist of that is this. Let's look at our first numbers here. 1, 2, 3, 4, 5, 6. If I asked you to list all factors of these numbers, the only factors of 1 are 1. Factors of 2 are 1 times 2. That's the only way you can get 2. Factors of 3 are 1 and 3, the only way to get 3. But factors of 4, you can have 1 times 4 and 2 times 2. Factors of 5 are 1 and 5. And factors of 6 are 1 times 6. And you can also do 2 times 3. So the only ones that would be prime numbers are the ones that have exactly 2 factors. So 2 would be prime. 3 would be prime. And 5 would be prime of those numbers. Composite numbers would be 4 and 6. And just as an FYI, number 1 is neither prime nor composite. It only has 1 factor, and it doesn't fit either category there. So when we do prime factorization, what we are doing is we are breaking a number down. We are breaking a number down. Breaking down a number so that it is the product, which means the end of a multiplication problem, of all prime numbers. Of all prime numbers. So for example, let's say I have the number, well, I guess we need to do this first. There are 2 different ways that we can do these problems. One way is, let me give myself a little more screen. One way is to do a factor tree. That's method number 1. Method number 1 is a factor tree, or the tree thing. And that would mean if I had the number 12, if I was told to prime factorize 12, prime factorize 12, I'd write my 12 down, I make little branches of my tree, and I say, what times what gives me 12? Well, logically, we go 2 times 6, and that is correct. Then you look at your answer here and you say, can I break those numbers down more? I can't do anything with 2. It is a prime number, so I stop with it. But the number 6 can be broken down into 2 times 3. Then I look at those answers and say, can I break those down? And the answer is no. So once you get to the end of all your tree things, the prime factorization of 12 is 2 times 2 times 3. But you know, if you remultiply this, 2 times 2 is 4, and 4 times 3 is 12, you will get what you started with. These are all prime numbers. They are the prime factorization of 12. Another example might be, let's say, 16. What times what gives me 16? Well, I could go 4 times 4. Neither one of those are prime. They can both be broken down. So I get 4 is 2 times 2, and the other 4 is 2 times 2. Those are all prime numbers, so there is how I stop. And you want to rewrite this in order from least to greatest, because when I read the answers, we all kind of want to be in the same order, so it just makes it easier for everybody to do. Oops. Now, I said there were 2 different ways to do this. One way is the factor tree way. The second method, method number 2, is what's called division by primes. And let's say I have the number 48. I'm going to start down here because I need a little room on top. And basically, division by primes, it says, is just exactly what it says. You are trying to divide by prime numbers. And helpful a little hint here, if it's an even number, always just use 2 as your division by primes, because it's easy to cut things in half. If I divide 48 by 2, I get 24. And then I keep dividing until I get all prime numbers left. What number goes into 24? And this has to be a prime number. Don't use 4 because that's not prime. That's why I was used 2. Half of 24 is 12. 12 can be cut in half again and get 6. And 6 can be cut in half again to get a 3. All of your answers over here are the prime numbers that get multiplied together to get your answer. So the prime factorization of 48 would be 2 times 2 times 2 times 2 times 3. If I remultiply all of those again, I will get 48. Let's go with a new page here. Let's do another one like that. Prime factorize 100. Well, if I'm doing 100 by division of primes, like I said, always use 2 if it's an even number. Half of 100 is 50. Divide 50 in half, you get 25. And now here you look at it and you go, 25 isn't even, so I don't want to use 2. What number goes into 25? 5. And what gives me that? 5 times 5. So the prime factorization of 100 is 2 times 2 times 5 times 5. If you're given the choice, I would say if it's a big number, sometimes division by primes is just easier, especially if it's a big even number. Otherwise, the factor tree would be the thing. Let's do just one more. Let's do the number 60 by both methods. Let's do a factor tree. What times what gives me 60? Well, 6 times 10. Neither one of those are prime, so I split those up. This is 2 times 3, and 10 is 2 times 5. All of those are prime, so I can stop. The prime factorization of 60 is 2 times 2 times 3 times 5. And again, I like to try to order them from least to greatest. If I was doing it with a division by primes, it would look like this. I can't use 6 here. Remember, this has to be a prime number, so I always want to try to use 2 to cut it in half if it's an even number. 30 can also be cut in half. You get 15. 15 you can't cut in half, so you have to think of a different prime number that would give you that, and I would say let's go 3, and 3 times 5. You can't divide 5 by anything but 1, so there again. Here are your prime numbers that get multiplied together to give you 60. So your answer is 2 times 2 times 3 times 5. Hopefully, boys and girls, that helps you out. Just kind of a fun little thing, and we will be doing a lot of this, so it's good to get some practice there. I'll stop sharing my screen, and we'll get over here. And thank you for tuning in today. Have yourself